Hello, I'm Cypher, and this video will explain how to use a tool I made to explore a particular system I built recently. It's called Atomic Clusters, and it's inspired by the work Clusters from Jeffrey Ventrella. Link is in the description. So I've written an article to explain exactly how this simulation works, how the mathematics behind it works, and the logical rules behind the system. So I suggest, if you're interested in it, to follow the link also provided in the description. That goes like in depth in how to implement this system. But this video is aimed at presenting the tool. So to use the tool, you can just download it. You also have to download the latest version of processing. Once everything is downloaded, you can launch the sketch file. It will open processing, and from there you can just execute the project, and it will open the tool. So what is atomic clusters? It's an attraction repulsion system between particles. So some particles are attracted to others and some are repelled. Basically, the particles are not attracted on their center, but they have attraction points represented by different colors in the tool. So if we take this example, we can see that particles of the same color are attracted to each other. Here the blue is attracted to blue, red to red, and the particles can adjust their angle so that they can attract, so that the same colors can end up on the same point. This is due to a torque generated by the forces not applied to the center. Again, this is detailed in the article I provided in the description. Okay, so the tool is pretty simple. You can basically set the number of subatomic particles that exist in this universe. So if, for instance, I select 3 subatomic particles, it means that particles of the same color will be attracted to each other. But for instance, in this case, the green particle is repelled by blue and by red. And more generally, particles are repelled by the particles that are adjacent on this circle. So if, for instance, I take 6 different subatomic particles, the blue will be repelled by red and green, but not by the 3 other subatomic particles. We'll just play with 4 different colors in this video, but well, if you want to explore this system, you can basically set up to 8. So the tool works by adding some particles into the world. You can do so by left clicking, and if I press the space bar, it will play and the simulation will run. And basically you can just add particles, that's it. And you can just see what happens where you add the particles and how they interact with each other. You can create your own atoms, so the particles are called atoms. This is again detailed in the article. I suggest that you read it if you want to know about this simulation. But if you just want to use the tool, you can add some atoms to the toolbar here, and you can create your particles using this tool. So for instance, if I want 2 attractors, one blue on the right and red on the left, I can do like so. If I want a third one that is, let's say, yellow, okay, I can do this, and I can add it to the atoms bar. Once it's added on the top here, I can select it and add it to the simulation, and now we can interact with the same rules as I described previously with all the other particles and create patterns. There is a list of different shortcuts that you can use to interact with the simulation and the particles. You can get it by clicking on this icon here. So for instance, if I press the A key, it will add way more particles than just left clicking. It can be useful like to explore fast structures. So we can already see that the particles interact with each other. There is a last thing you can do it's to play with the simulation settings. So for instance, the max speed is the maximum speed a particle can reach. Magnetic strength is the general strength of these color charges. So the higher it is, the faster they will get closer to each other. The attraction range is the range within they can see each other. So if I increase it, you will see, for instance, that these particles start like to move towards other particles they were not able to reach previously. This setting is for how much energy is transferred upon collision. So the higher it is, the more unstable the system becomes. Attraction strength and repulsion strength is obvious. Like if there is no repulsion, they will only be attracted to each other, but if the repulsion is really strong, given the rule of adjacent particles on this circle, they will repel each other. Well, in this case, they all repel because they have different charges that cannot accept being next to each other, and because the strength is way higher than the attraction, because the repulsion is way higher than the attraction, they get repelled. I will just lower it a little, so now they're attracted to each other again. Friction, the higher it is, the less the velocity stays over time. Spun radius is used for the radius of the particles you add to the simulation. And the charges distance center, well, as you can see, is the distance of the attractors to the center. If it's higher than 1, the system becomes weird, yeah, to say the least. I suggest that you leave it under 1, and preferably under 0.7 if you want interesting results, but well, explore it as you wish. Okay, that's it for the presentation. I will just try to play a little with it. You can select a particle and, well, if you select it, I will lower the attraction range because there are too much. Okay. You can see the forces applied to each of the points. That could be useful. By right-clicking, you can also move the particle. Okay. And you can rotate it by pressing R. It can be fun, like if it's around other particles, like it creates some interesting effects. And you can remove it from the simulation by pressing delete, the delete key. And by pressing enter, it resets the simulation to its original state, so everything's empty. And you can add some more particles. Keep in mind that the tool is currently in its early stages, so optimization is like not really good right now, but I'm planning to improve that point in the future. Thanks for watching the video. If you have any questions, let me know in the comments, and have fun exploring this system.